Kia ora koutou. My name's Jun. I'm a product manager at NeSI. I'll talk a little bit about how we are embracing the changing eResearch landscape and what are some of the decisions that we made to prepare for it. So how is the eResearch landscape changing? So we are seeing in the past many years, eResearch is being adopted across a lot more science domains and like domains such as humanities, political science. There's a lot more acknowledgement in need of looking at data, and there's definitely growing data along with machine learning and AI use cases. Also, along with that, there's growing ways of doing e-research. So NeSI's been providing access to traditional HPC, but there's also a lot of public and commercial sectors providing new tools and technologies, and they're really intertwined with science now. Also, there's much more accepted acknowledgement that around the needs of data privacy and sovereignty and security concerns, not just on science, but with public. And then all of these changes, the rate of change itself is increasing. So to adapt to all of these changes, NeSI has started this journey of creating a new platform called Flexible HPC. So this is sort of like an underlying platform that can host a whole bunch of computing resources that can be used for cloud as well as high-performance computing and GPUs for AI machine learning use cases. And we began this journey together with eResearch. Ben Taylor has just given a talk in previous session on our collaboration. And a couple years ago, we've also launched our Research Developer Cloud, which is similar to AWS or Catalyst, where like computing resources are available through the cloud, and you can set up you can customize it to your needs. And with that, we recently also collaborated with Genomics Aotearoa to host and develop Aotearoa Genomic Data Repository, which is one of the data repository use case, which is, again, different to traditional HPC use case. And also we've recently collaborated with Aotearoa, where the key there was to enable scientists to do research securely on a very sensitive human data with like full respect to Maori tikanga aspects. So right now we are moving towards in the process of provisioning the NeSI's next new HPC, and there's a couple talks happening tomorrow with Nick and Blair going into a bit more details on that, so I won't touch on too much, but all of it's possible through our collaborators and platform partners. Just starting with some of the technology choices. So for our new HPC, we have chosen Weka as our high performance file system for HPC. And one of some of the key reasons for this is, again, it is incrementally expandable. So as we identify new use cases and different scenarios where we need more data, it gives us that expandability. And also it has a tiered storage solution, which enables a very cost-effective way to expand the underlying object storage. And you can carve out parts of Weka in such a way that it can be configurable into an isolated file system, so that addresses some of the data sovereignty possibilities. And we've also gone with Versity for our new service called Freezer, which is our tape archive storage. And again, it is incrementally expandable and comes with intuitive UI, which we kind of was a big challenge for us in our past archive solution. Here's a sort of a very hard to understand diagram of our how we utilize Weka. So NeSI compute cluster mounts the Weka file system, and possibly other future services can also share the file system as well. I think the outlines are not rendering correctly on that, but they should have boxes there. But Weka abstracts away that elements of tiered storage. So underneath Weka, it's got really high performance NVMe storage and more cost-effective object storage, which could be expanded with minimal disruption to what's consuming them. And all of that relates to how we also develop the services for the new HPC as well. So we are really focusing on using infrastructure as code approach. And by this, what we mean is that we're not just getting some cloud virtual machines and deploying things, doing things manually, but rather than that, we're doing all the processes as code and capturing all the changes into Git, and that way, it's like writing a recipe as opposed to just going out there and cooking randomly. So it gives you ability to track all the changes and easily iterable, and you can collaborate easily. And we are learning a lot from our partnership with eResearch as well. And as a prime example, eResearch has used Stack HPC's Slurm appliance to deploy their Slurm cluster, which is the compute scheduler, and we've forked that and tailored it to our needs. So one of the examples of as-code approach is our what we called Slurm cluster steel thread. Steel thread, you can imagine like a sort of a thin steel line that goes underneath like a construction site, so you can put stuff on it. So we are building a very bare bones Slurm cluster using our cloud infrastructure while the new hardware is being set up in parallel. So instead of using the actual hardware, we start by developing the identity, scheduler, and storage using our cloud services. So this looks really complicated, but it's just different parts, most basic parts that was needed to replicate our HPC Slurm service. And each of those started off as like components in the cloud, our cloud. But as we get the new hardware ready, they get iterated and replaced with the real deal. So I mentioned the cloud. This is something that we launched a couple years ago. Research Developer Cloud enables you to have your own space where you can deploy VMs, your own software stack, and so on. And we use OpenStack technology, which is pretty commonly used in various other research institutions. And the key here is that OpenStack provides an API, which means your code can interact with it, and you can use code to provision VMs and configure networks and stuff like that. And essentially, what you're doing is writing a code that takes resources from a pool of cloud compute, and it could be like compute, network, or storage, and then takes into your project space and set it up the way you need. Another example of as-code implementation is our new on-demand environment. So this replaces NeSI's current Jupyter Hub, which is used for interactive applications. And a lot of this comes from our previous on-demand installation that development that we've done for the training environment that NeSI's been using, and Kahu over there will give a talk on Thursday on more details on the training environment, and we were able to extend that code base and apply for our upcoming HPC. I'll skip this one. So here's what on-demand interface looks like. So currently we only got Jupyter Lab in our studio, and this is Jupyter interface, so it lets you write Python and interact with it on the web. And here's a sort of early underlying architecture diagram. I won't go into details, but all of these are defined in the code, so we can iterate and easily redeploy and make changes. All of the changes are being tracked on our GitLab pipeline, so whenever we make changes and deploy, it gets captured. It's got all the timestamps and whether it passed all the tests and stuff like that, so it's really nice and handy. And you can select different environments where you deploy into. So this shows that you've deployed Jupyter into the test environment, but there's also records of what's been deployed into sandbox or production or things like that. So you can do more risky testing on the test environment, and once all the tests are passed, you can deploy into production. We also have a S-code pipeline for our upcoming new HPC cluster. So this uses sort of Linux-based images and uses technology called Pekka to turn into something that can be consumed by the HPC, and it basically turns an image, builds a base image that contains all the necessary applications installed so that you can deploy into a service called MES, which is short for Metal as a Service. So that's another service that we are relying on to provision our new upcoming HPC. So MES is actually similar to OpenStack in a sense that it shows a pool of resources and you can deploy things into it, but this is more to do with our specialized HPC kit, and lots of, it's different to the cloud in a sense. You don't just, actually I'll skip what I was about to say. I don't fully understand. But anyway, so in terms of where we are headed, we are reshaping our new infrastructure such that it is able to adapt and reconfigure easily, as opposed to traditionally applications having to adapt to a rigid infrastructure. And the approach, infrastructure as code, enables us to continue to iterate and collaborate, and it is an ongoing process. And it opens up exciting new possibilities such as cloud and HPC integration, and being able to carve out isolated research environments so that you can do sort of secure research with data sovereignty concerns and much more. And I'd like to thank all my colleagues. They've done all the work. I'm just doing the talk. Thanks.
Thank you very much, Jun. Are there any questions? So the as-code approach that you mentioned. You know, Okay, the as-code approach that you mentioned, you know, how easy is it for you to distribute that for other groups so that they can kind of use that themselves?
Yeah, I think it's actually quite straightforward. So there's a lot of open source practices that helps you share the code base. You can make it public, or you can just share it with other people. And I think it's maybe Kahu could add a bit more, but it's a matter of cleaning it up so that it doesn't have any proprietary information exposed, then I think we can easily share it with other people who's trying to do similar things. So, yeah.
Great. Thanks, Jun.